In hoop stress, in diameter, FH equals to PD by 2T. If it is in the radius, PR by T. Okay, this is the hoop stress. And the next one is longitudinal stress. Here we can see that longitudinal stress formula is FL equals to PR by T. If we need to consider the radius side, PR by 2T. If it is in diameter, PD by 4T. This is the longitudinal stress. Here we can see that the longitudinal stress is, here we can see, thus hoop stress is twice the longitudinal stress. Okay, this is the important point, consider it as important. Thus hoop stress is twice the longitudinal stress. Okay, see here the maximum stress, the maximum shear stress. Here we have learned that hoop stress and then longitudinal stress. Here we are going to learn the maximum shear stress. See, in this topic, at any point on the circumference of the cylinder shell, there is a set of two manually perpendicular stresses, FH, that is a hoop stress, and FL, longitudinal stresses, which are principal stresses, and as such the planes in which these act are the principal plane. Where these principal stresses act, the plane is called as principal plane. Okay, the maximum shear stress is, this is sigma max equals to FH minus FL, hoop stress minus longitudinal stress by 2. Here the formula they substituted, and here we go for the final formula. The maximum shear stress equals to PR by 4T or PD by 8T. This is represent in R, this is D, radius and the diameter. And the next topic we go here is design of thin cylinder. In this topic we learn that if wall thickness of the thin cylinder shell is to be determined so that it can be withstand a given internal fluid pressure P, then we have to ensure that the maximum stress developed in the shell does not exceed the allowable tensile stresses PT of the material of the shell. Here we can see that hoop stress is bigger, so we design the shell for it. As hoop stress equals to PR by T, here we can see where T is the required shell thickness, but FH, hoop stress, should not exceed permissible tensile stress for the shell material PT. Here PT is the permissible tensile stress, FH is the hoop stress. Here we compare when we hoop stress is less than or equal to permissible stress. Here hoop stress formula PR by T is less than or equal to permissible stress PT. Here when with this come here like this, T is less than or equal to PR by PT. This is the permissible stress, that is thickness what we design for the thin cylinder. Design of thin cylinder, here T is less than or equals to PR by PT. And the next topic, here we see that strains and changes in dimensions in thin cylinder shell due to internal pressure. Here we have completed up to here the stresses, and now we are going to learn is strains. Let hoop stress and the hoop strain longitudinal stress are the hoop stress and the longitudinal stress is developed in the shell material. Also let in strains we consider that Poisson's ratio, that is 1 by m, and the modulus of elasticity of the cylinder material is E. Here we continue this. See here hoop strain. For hoop strain we have the hoop strain formula like this. E. For stress we represent it as a FH. For strain we represent it as a EH. Okay, hoop strain 1 by E in bracket hoop stress minus Poisson's ratio into hoop longitudinal stress. See here E is the modulus of elasticity of a thin cylinder, and this is the Poisson's ratio, and this is hoop stress, and this is longitudinal stress. When we substitute the formulas of the hoop stress and the longitudinal stress, here we get the original formula of the strain. Here hoop strain or circumferential strain. Here hoop strain formula is EH equals to PR by TE in bracket 1 minus 1 by 2m. We'll get this formula by substituting the hoop stress and the hoop strain longitudinal stress formulas in this. Okay, this is the hoop strain formula, and when we go to the longitudinal strain, Same like the substitute the formulas and we get the longitudinal strain formula EL equals to PR by TE in bracket 1 by 2 minus 1 by M. This is the longitudinal strain formula. And we have the third formula, volumetric strain, that is, here we go for the final formula. Volumetric strain EV equals to PR by TE in bracket 5 by 2 minus 2 by M. These are the topics and the formulas today we have learned in this session. Okay, tomorrow we'll do the problems in this chapter. These are the chapters. If you have this textbook, be ready with this textbook. Tomorrow we'll go through this. Okay, post me if you need any related this chapter topics or any questions you need to solve. Please post the comments. Okay, bye bye, see you in the next section.